So I'm always watching videos, always trying to learn more things, gather more information. Um, I know what I know, and my goal, I tell Abba all the time that I want to be used by him to draw as many people to him as possible. It's been said in a couple videos by people who delve into certain things. They say that this generation is very special to God. I hear them say that this generation is very special to God. Today, as I was on the train, I meditate on God all the time. If you ever see me in public and you catch me smiling, I'm thinking about the oh man. So today on the train, I was thinking about why this generation is so special to God. God does everything according to plan. He's a very meticulous God. That's how he is in all that he does. You see the meticulousness in which the DNA and your body and the cells function. They're so meticulous. Everything is detailed. This does this so that this can be done, and then this comes here to do this, and then that does this, and this can't do that because if it does this, this will be damaged. So this has to do this, and then this comes and this has to attach with this to counter that. And then he's very meticulous. But when you read Numbers and Deuteronomy and Leviticus, you see the same meticulousness in it. When you create this, make sure that this person doesn't have this, and make sure that they use this material, and it must be carved to these dimensions, and this has to be added with this. Everything is so scrutinized in all those books that it gets kind of like annoying reading all of that because it's so detailed. It's so meticulous. Well, the same one who meticulously made the cell in all his meticulousness, because he's a clean and holy God, he put the same thing in the book. But okay, so I was pondering, why is this generation I wasn't pondering that question, but I was pondering over many different things about the Almighty, and it dawned upon me why this generation is so important to the Almighty. Like I said, God does everything according to plan. It was God who advanced the technology of man. And he did this through the space race, because of the space race, that's why technology has advanced so much, because everyone's trying to reach the moon. And I don't believe they've been able to do that because no one can go past. But anyway, God has advanced technology to where it is now so that knowledge will increase. And knowledge will increase not just for any random sort of knowledge, but specifically knowledge pertaining to the Almighty and the good book. That was his aim in increasing the technology of mankind for that purpose, so that no one will have an excuse to say they didn't know. Why? Because everything is literally at your fingertips. In the book of Daniel, God told Daniel, through an angel, that the book should be sealed until the end of days. And in the end of days, people would move to and fro, airplanes, automobiles, trains, bullet trains. People will move to and fro, and knowledge will increase. Why is it that knowledge will increase in the last days? Because God will make it so. So that now, not only are we learning about, before I touch on that, God is also going to bring upon us Armageddon. Now you have to understand, Armageddon is no joke, people. The reason why Armageddon is so justified whenever it comes is because literally nobody has an excuse to deny God's existence. At this point in time, evolutionists have no excuse to deny God's existence. It's gotten to the point where it's either you say there is a God, or you don't know if there's a God or not. It's either you say there is a God, or you say you don't know there is a God or not. Because to say that there is no God you're literally being blind. So let me give you some examples of why Armageddon is so justified, and I can't wait for Armageddon to come to wipe the filth and the faithless people off the face of the earth, because they so deserve it. Try to finish this in a short period of time, so I'm gonna be missing a lot of information, but it's because I'm trying to keep my videos short from now on. You know, every person, every scientist who is at the top of their field always comes to the point in their career where they acknowledge that there has to be a God. When they were more ignorant of their field, they were able to speculate in their mind that things can happen. A perfect analogy of this is when a kid can imagine that Superman can fly. A kid can fantasize that Superman can fly. To them, all you need is a red cape and you can fly, because a child is ignorant of the laws of physics. Once he becomes knowledgeable about the laws of physics, he becomes a man or a woman, he will realize that no, Superman can't fly. It's not possible, because he's come to know enough about the laws of physics that it can't be done. This is why, you see, you have to look into the field of origin of life, and then look into the field of evolution. But start with origin of life. Because once you are able to see that origin of life, researchers have not been able to prove that life can come through chemical reactions. Everything else goes out the window. When all these people, scientists who are experts in their field, whether it be geology, biology, origin of life research, thermodynamics, laws of physics, all of them, when they reach the epitome of their field, they all concede that there is no way that this came about by chance. As a matter of fact, let me give you some examples of some of these people. One man, I forget their names because it's honestly, their names are not important. The only name to me that's important are biblical names and obviously the Almighty. But I forget his name, but he's the author of Chemical Predestination. The idea about that book was he believed that chemistry, in order for chemistry to create life, he believes that they need some type of way of action that inevitably leads to life. Otherwise, it can't be done, right? Because they know enough about chemistry that can't be done. So in his research, that was what the book was based on. As he was writing the book, he came to see big flaws in chemical evolution. Now you have to, man, I don't think I'm going to be able to explain all of this in less than 11 minutes, less than 12 minutes. After the book was released, he already admitted while he was writing the book that he disagreed with a lot of things that he wrote. And as his knowledge about chemistry increased, he realized that there is no way that the DNA can form. There is no way that biopolymers and proteins can form. It just cannot happen. When, as a matter of fact, oh my goodness, there's so much. Oh my God. Okay. How do I cut this short? Chemicals, when they react, they either stop or they continue to react until it runs out of its material and it stops. Right? So if you're baking a cookie, that's chemical, that's chemistry. It's either the cookie stops baking because there's nothing to power it to keep moving it along, or if it keeps moving along, it just keeps going until the cookie burns and it stops. Okay, so in order to arrive to life, you know how many things have to happen perfectly. For example, it has to reach a specific temperature. If it's above that or below that, that part of the chemical reaction stops. Once it reaches whatever it needs to reach, it needs to be stopped, frozen, and preserved, and kept clean, uncontaminated. In the natural world, this is just a quick example because I don't have much time. I think I'm going to go live, and I'm going to refer to this video when I go live. But I probably would have. Okay. The chemistry of life is too pure. It's too pure. In nature, it will never get started. Just keep this in mind. Like one of the things they mentioned was nature is too dirty to create life. It's too dirty. Life is too pure to arrive at life. When humans with all their intelligence try to duplicate the process of life, they have to use sanitized conditions. They have to use pure, potent chemicals, which you will not find in nature. Okay? They have to preserve and stop the reaction by freezing it. And even that sometimes is still not enough to produce what they want. So how on earth could it have happened on Earth? In nature? It is impossible. So what I'm trying to say is that the evidence against evolution is so daunting that if you don't believe in God, Armageddon suits you right.
Rob Stadler, who is the author of The Stairway to Life, a book on the topic of the origin of life, which we will be talking about today. Rob received his bachelor's in biomedical engineering from Case Western Reserve University, a master's in electrical engineering from MIT, and a PhD in medical engineering from the Harvard MIT Division of Health Sciences and Technology. As a scientist in the medical device industry for over 20 years, Rob has obtained more than 140 US patents, has been elected fellow of the American Institute of Medical and Biomedical Engineers, and has contributed to medical devices that are implanted in millions of patients worldwide. So, Rob, thank you so much for coming onto my channel.
And this is starting at a very high level, very simple here. We know enough about physics and about chemistry and about biology. We've learned so much over the years. We know enough to know that it can't be done, that those natural processes can't be responsible for what we know life is. And I like to use an analogy here of a couple of 100 years ago, 200 years ago, people tried to build a perpetual motion machine. People would, in their work laboratory, try to build something, keep trying. And then we got to the point where we learned enough about thermodynamics and about physics to say, this is not possible. You can try forever and ever, and you will never build a perpetual motion machine. And so people hopefully have stopped working on that, and governments don't give grants on working on that anymore. And I really believe we're at that point when it comes to explaining origin of life from a natural standpoint. We all know, all of us have observed with our own eyes, when a living thing dies, what happens? What is the natural process? You know, there's a natural, one-way, universal, unavoidable, irreversible degradation of the living thing, the complex chemicals that make it up, and the organization of those complex chemicals all begin to fall apart. And it all goes back to dust, back to basic, simple chemicals. We're all familiar with that. We've observed that. We're all scientists. We know what happens. So to believe the opposite, that just natural processes on their own take basic, simple chemicals and build them up to more and more complexity and more organizational structure until you actually have something that's alive and can reproduce. It goes against everything that we observe in life. So again, it's not a natural process.
If you
use methane and ammonia, in other words, the so-called reducing environment, with some hydrogen gas present, you can get plenty of organic materials produced. And yes, it was very encouraging to the proponents of the theory when amino acids, a few amino acids, were discovered in the flask. In fact, over the years, more than a dozen such amino acids have been found in the Miller-type experiment.
How close is the development of amino acids to the threshold of life?
Well, you have to have many things besides amino acids. And if you only produce the suite of amino acids that are necessary for living things, and there is a subset of 20 amino acids that we know in living things, you need those, but you need many other compounds and chemicals. But let's just deal with the proteins or the amino acids as their components first, because in these simple experiments, simulation experiments, you produce not only that set of amino acids, but many other amino acids. There are far more amino acids that are produced, and even in greater abundance than are produced of the 20 amino acids. And so you mix all those together with all of the other chemicals that are being produced, and you find out that the interfering cross reactions of these just prevents any type of meaningful buildup of chemicals that are sufficient to go on to the next step in making life. So it's a very difficult, almost intractable problem, I would say, chemically.
What are the steps involved in producing proteins from amino acids?
Well, the way typically these experiments are done, you do an experiment, you produce a glycine, an alanine, and a few other amino acids that we know exist in living systems, in true proteins, for example. And then you isolate those amino acids from the system, and you purify these amino acids, and then you use these amino acids separated, isolated from the myriad of other chemicals that would have been present in a, quote, prebiotic soup of chemicals. And then you react these amino acids together under other conditions to produce polymers. In other words, you're trying to build up, see if you can simulate the production of a protein.
Why are amino acids isolated during this process?
We want to separate the chemicals from each other in different stages of simulation experiments so that we can get a realistic handle on how the developmental process of chemical evolution occurs. If you don't do this, you have all the different chemicals mixed together and they will mutually interact and react with each other. Now, why this is bad, or what happens is, amino acids will combine with amines or other groups that have say a carbonyl group, and you will get dead end process. You won't get meaningful substances.
What do you get?
Just a goo, just other substances that don't have any biological significance to them. And this is the really difficult part in trying to conceive how to do a simulation experiment. It's well known, nearly every one of these experimenters know that you can't do a realistic experiment according to what the theory says and get meaningful results. It's well known, nearly every one of these experimenters know that you can't do a realistic experiment according to what the theory says and get meaningful results. You can't do a realistic experiment according to what the theory says and get meaningful results. But if you just did that, everybody would get the same glop, and it's not a meaningful result. And so you have to have meaningful results to publish, and that's the reason why you separate things. So you can get have an idea of how you're going step by step to produce to go along the process of making life.
How can the investigator affect the outcome of a simulation experiment?
Well, you must have, in any kind of a simulation experiment, the role of the investigator. I mean, it's impossible to do experiments without the investigator. So when we wrote our chapter on the role of the investigator in these simulation experiments, we were trying to point out and make a distinction between those legitimate interferences in the experiment, such as stopping the experiment at a certain time and withdrawing sample for analysis. That's legitimate. You can do this. The experimenter can set up the laboratory conditions and set the parameters of the experiment, and that's fine. These are the kinds of investigator role that you would expect. What is illegitimate, and we felt like needed to be brought to the attention of students and other professors who were investigating this and brought it out into the open, because, believe me, it's never brought out into the open. You can go to these international meetings, and there's two things that are almost never brought into the discussion. One is the problem, as we've already mentioned, the role of these interfering cross reactions. If you discuss the role of the interfering cross reactions, there would be no other place for the conference to go. You would just focus right there. It would stop. There wouldn't be anywhere else to go because you can't have any meaningful results. So nobody talks about it. That's frankly the way it is. The other thing is that besides the interfering cross reactions, you must not talk about in these conferences the role of the investigator to interfere in an illegitimate way with results, because if you did, it would become obvious that most of these experiments are unacceptable according to their own criteria for what we're doing as prebiotic simulation. That means, by the way, let me explain what I mean by that. According to the theory, we want to reproduce in a laboratory setting conditions that would have been on an early Earth 3 to 4 billion years ago, and that means no interference from God or any other outside forces, and either then or since. So we make a naturalistic assumption from the beginning to the present. Well, that means then that we cannot have, if we're going to simulate those conditions, we cannot have an investigator constraining the conditions that are outside the boundaries of what we've already said were acceptable for that prebiotic Earth.
How did you evaluate the different chemical evolution experiments?
Basically, we put the scale in such tentatively drawn. I mean, if we can show that it fits the parameters of a legitimate prebiotic experiment, then yes, by all means include it. And we'd be glad to move our line one way or the other according to how the data goes. But so far, the experiments are such that the investigator's role prejudices the outcome of the experiment in an illegitimate way. I just find it intolerable that men of science can allow this to go on and not make it vocal and not make it open, and certainly not, be more specific in their research papers. As I mentioned earlier, though, the reason why we don't do it, why it's not done, is that if you did, you wouldn't get meaningful results. And you can't publish a lack of results. You can't just do a research paper and say, well, I'll publish a paper of what I've done the last 2 months that hasn't worked. You've got to have some results. And it turns out that in 40 years of all these experiments, by and large, now there are a few exceptions, but by and large, most research papers have fit the category that we would call illegitimate, because the experimental parameters are constrained in such a way, the conditions are constrained in such a way that it would not fit a prebiotic Earth.
In the statement we were looking at there about no way to scientifically investigate the question of a designer, two sciences I can think of know how to look for intelligences. And those two sciences would be archaeology and what we might call a branch of astronomy called SETI, Search for Extraterrestrial Intelligence. In archaeology, an archaeologist or an anthropologist may pick up a chipped stone from the ground and ask himself, how did this stone come to be chipped? Was this stone chipped because it fell from that cliff up there and bounced off a few rocks on the way down? Or it was lying in a stream and water freezing and thawing perhaps in the winter has chipped off some stones? Or was it carefully chipped by a workman who was working on it? Well, if there's only 3 chips off the thing, you probably can't tell. But if there are 100 chips off the thing, and those 100 chips are aligned in such a way that they make a pretty good arrowhead or spear point, I think you can feel quite confident that you are looking at evidence of an intelligence behind it. The placement of 100 chips on the surface of a axe head or spear point or arrowhead is a good indicator that that is not merely something that happens to look like an axe head, spear point, or such, but that it really is such a thing. Well, how much information is the placement of 100 chips? Well, it's 100 triplets of locating that in 3 dimensions, let's say relative to the center of gravity of that particular piece of rock, if you like. So it's about 300 pieces of information, or if you think of a couple decimal places, you could run it up a little further, but it's like that, all right? How would a person searching for extraterrestrial intelligence tell whether signals coming in from outer space through a radio telescope antenna, whether they are little green men or whether they are pulsars rotating very rapidly? That was a question that arose to Jocelyn Bell and Stanley Hewish when they were first looking at the pulsars when they were discovered. And the answer, I think, would be you would examine the signal, and the placement of perhaps 100 or 200 or 300 signals would tell you whether it might just be some kind of rotation phenomena or whether it looks like what we might call the organized complexity that is more characteristic of a language. Carl Sagan, in his science fiction novel Contact, investigates this particular question again. It would seem then that perhaps 100 or 200 or 1,000 pieces of information, digits of information, bytes of information, would be enough to tell whether you're looking at something random or whether you're looking at something that is real, intelligent, if you like, or an intelligent designer lies behind it. Interestingly, the most complicated thing we know of in our universe is life. And the information content of even a simple E. coli bacteria, it's a prokaryotic cell, not a complicated one, etc. Sagan says in his article Life in Encyclopedia Britannica, the information content is equivalent to 10 to the 12th power bits, or about 100 million pages of the Encyclopedia Britannica. And it's not just random stuff. It's making a working machine. That sounds to me like we are getting a message from E. coli that it was designed, and that a person who claims that anything else is happening is under a certain obligation to show how such a thing could have designed itself. And not just by waving hands, but at least by some kind of computer simulation that you can get from the kind of information content in simple molecules up to the kind of information content of 100 million pages in Encyclopedia Britannica by random processes, even though constrained by natural laws.